Have you ever just looked up at the night sky and wondered, where did all of this come from? I mean, not just the stars and the planets, but everything. Reality itself. What happened in that very first moment? Well, that's the giant mystery we're diving into today.
It's maybe the biggest question we can possibly ask. And for literally thousands of years, philosophers, scientists, thinkers, they've all tried to crack it. Today, we're going to look at one of the most powerful, and one of the most controversial arguments ever made about it.
It's called the Kalam cosmological argument. And on the surface, it's so simple, it's almost elegant. Just 3 little steps. First, whatever begins to exist has a cause. Seems obvious, right? Second, the universe began to exist. Okay, which leads to this massive conclusion. Therefore, the universe has a cause. It looks straightforward, but trust me, every single part of this argument is a battleground.
So, how strong is this argument really? That's what we're going to find out. We'll trace it from its ancient roots right up into modern science. We'll look at the 2 huge scientific discoveries that seem to back it up, and then we'll dive into the biggest counterattacks from both philosophy and quantum physics. And finally, we'll ask, where does all this leave us?
All right, let's get into it. First up, an ancient argument, modern science. You might think this is a recent debate, something that popped up with the Big Bang Theory, but the core idea has been around for over 1,000 years, making a long journey from medieval theology right into the heart of modern cosmology.
So the Kalam is definitely not new. It was actually first put together way back in the 11th century. A brilliant Islamic theologian named Al-Ghazali used it to push back against the old Greek idea that the universe was just eternal. It was developed for centuries after that, but it really had a modern comeback in the 20th century, when philosopher William Lane Craig basically supercharged it, connecting this ancient logic with cutting-edge 21st century science.
So the logic is ancient, but that second premise, the idea that the universe actually began to exist, that's where modern science really comes into play. Which brings us to section 2, the case for a beginning. Why are most scientists today pretty much convinced that our universe is not eternal?
Now, you might think there's a mountain of evidence, and there is. But here's the wild part. It seems to follow a kind of scientific 80-20 rule. Our source suggests that just a tiny fraction of the evidence, about 4%, provides a whopping 64% of the argument's scientific power. What that means for us is that we can zero in on just 2 key discoveries that do almost all of the heavy lifting.
And these 2 discoveries, well, they're what you might call the scientific showstoppers. They're 2 pieces of evidence so powerful that they create a massive, massive challenge for any model of a universe that's existed forever.
Think of it like a double barrier, a real 1-2 punch against an eternal past. The first is a geometric limit, a theorem called the BGV theorem. The second is a physical limit, the famous second law of thermodynamics, or entropy. You can think of the universe like a wind-up toy that's constantly winding down. If it had been running forever, it would have completely run out of energy by now and reached a state called heat death. So one limit is about the very fabric of space-time, and the other is about the stuff inside it. So, the BGV theorem, which came out in 2003, is a huge deal because it's so incredibly robust. It's not tied to one specific physical theory. It's a pure geometric proof about space-time. So imagine rewinding a movie of our expanding universe. You have to eventually reach a starting point. And the theorem shows, mathematically, that this is true for pretty much any model you can dream up. Cosmic inflation, even the multiverse. As long as your universe is expanding on average, the math says it simply cannot be infinite into the past. It must have a beginning, period.
The impact of this was just huge. Alexander Vilenkin, one of the physicists who developed the theorem, and he's not a theist, by the way, he put it very bluntly. He said, cosmologists can no longer hide behind the possibility of a past eternal universe. They have to face the problem of a cosmic beginning. So the crucial takeaway here is that mainstream science itself really seems to have closed the door on an eternal past.
Okay, so the science seems pretty solid on this point. But even if that's true, the argument faces a totally different kind of challenge, the philosophical counterattack. This whole line of reasoning moves away from physics and asks a much more fundamental question. Is an infinite past even logically possible to begin with?
Now, to get this, we have to understand that there are 2 kinds of infinity. A potential infinity is just a process that can go on forever, like counting. You never actually reach infinity. But an actual infinity, that's a whole different beast. It's a completed set with a literally infinite number of things in it. And the Kalam argument's core philosophical claim is that an actual infinity like that, say an infinite number of past events, just can't exist in the real world.
The classic way to wrap your head around this is a thought experiment called Hilbert's Hotel. Imagine a hotel with an infinite number of rooms, and every single room is full. But then a new guest shows up. No problem. You just ask everyone to move one room down, and poof, room number 1 is free. Weirder still, if all the guests in the even-numbered rooms check out, that's an infinite number of people leaving, the hotel still has an infinite number of guests. Now, proponents like Craig say this is metaphysically absurd. It works on paper, but it's impossible in reality. Critics like Graham Oppy say, hold on, it's not impossible, it's just really, really weird and counterintuitive.
And this slide really nails the core philosophical fight here between the argument's main players. On one side you have Craig saying an actual infinity is impossible in the real world, and you can't cross an infinite number of past moments to get to today. On the other side, Oppy argues that these ideas, while bizarre, are logically fine, and that a universe without any cause is actually a simpler explanation than a universe plus a God.
This philosophical rabbit hole leads us right into our next big challenge: quantum physics versus a cause. Could modern physics give us a loophole? Is there some way for a universe to just pop into existence from nothing, with no cause needed?
One of the most famous attempts to get around a beginning is the Hartle-Hawking model. Now, this gets a little weird, but stick with me. It uses a mathematical tool called imaginary time. In this mathematical world, time stops behaving like an arrow and starts acting just like another dimension of space, like length or width. The result is a model of the universe that's finite but has no sharp starting point. Kind of like how the North Pole is a point on a globe, but there's no edge there. The catch? Well, critics point out that this is all a mathematical abstraction. The moment you convert the math back to the real time that we actually live in, poof, that definite beginning, the singularity, it just pops right back into the equation.
So, what about that popular idea of a universe from nothing? This is a huge, huge point of confusion. When a physicist talks about something coming from nothing, they do not mean what a philosopher means by nothing, as in absolute non-existence. They're talking about the quantum vacuum, which is a sea of fluctuating energy that is governed by the laws of physics. That is absolutely not nothing. It's a very complex something that itself needs an explanation.
So, after all the science and all the philosophy, where in the world does that leave us? Well, in our final section, we're going to see if we can find some kind of final verdict by looking at a very modern twist on this very ancient question.
Okay, so let's throw in a modern wildcard: the simulation hypothesis. It creates this fascinating, kind of unlikely parallel to the Kalam argument. I mean, think about it. If we're in a simulation, then 1, the universe had a beginning the moment the program was started. 2, it has a cause, the programmer existing outside of our spacetime. And 3, it appears fine-tuned because its physical constants were literally coded into the system.
Ultimately, there is no easy answer here, and every single option has what philosophers call a metaphysical cost, a huge unproven assumption you just have to accept. Is it a completely uncaused natural event? Something that violates our deepest intuition that things don't just pop into being for no reason? Is it an infinite regress of causes, which runs into all those bizarre paradoxes of infinity? Is it a transcendent personal cause, which takes you beyond science? Or is it a simulated reality, which just kicks the can down the road to who created the simulators? There's no free lunch here.
And this brings us right to the final, crucial question at the heart of this entire mystery. The evidence strongly suggests our universe had a beginning. So what was that first cause? Was it an uncaused, natural event that seems to defy all logic? Or was it something outside of nature, something intelligent, powerful, maybe even personal? The question I want to leave you with is this: which of those two explanations ultimately requires the greater leap of faith?